Welcome to Let's Get to the Marks. This is a question from the 2024 AS Chemistry Paper 1 for AQA, and it's about the alkaline earth metals. So, just doing a walkthrough. Remember to pause the video at the start of each part to the question and then have a go. So, this question is about the elements in group 2. Explain why the third ionization energy of beryllium is much higher than the second ionization energy of beryllium. So what we have to think about here, beryllium has the numbers 9 and 4, mass number, obviously atomic number is 4, so it has 4 electrons. So that means we're going to have 2 in the 1s, 2 in the 2s. Obviously, when we remove those electrons, it requires energy to pull each electron out of their orbital. Now, the second ionization energy, we're going to be removing that electron from 2s1, because obviously at the start it's 1s2, 2s2. Now we've taken that first electron away, the first ionization energy, we've broken into that shell. But now that second electron is that tiny bit closer to the nucleus, but not much. And we're taking it away from a beryllium plus 1 ion. But why is it that the third electron is even higher? The second ionization energy is just removing this 2s1 electron. And it's from a partially filled orbital, which makes it a little bit less stable. Well, the reason why the third ionization energy is even higher, or there's a big jump, is because we're breaking into a new energy level. We're going from 2s1 to 1s2. So it's at a much lower energy level, and it's closer to the nucleus. And obviously, there's no shielding now because we've removed that second energy level, which was shielded by the first energy level from the nucleus. So we've got no shielding, closer to the nucleus, and breaking into a brand new energy level. And all of those are factors that mean the third ionization energy will be higher than the second. So there we go. We're removing an electron from the 1s2 instead of the 2s1, and that will pick you up your 3 marks. Awesome. All right, let's move on to the next part of the question. So 2.2, magnesium reacts slowly with cold water, but rapidly with steam. Compare these reactions in terms of the products formed. You should identify one similarity in and one difference between these reactions. So this is where, if you haven't done your revision, you'll be a little baffed. Now, the first one's not too bad because most metals react like this. And we remember from GCSE with the alkali metals, you drop them in water and they form a metal hydroxide and hydrogen. And the same here for the group 2 elements. We get a metal hydroxide, these are alkaline earth metals, and we get hydrogen. However, if you react magnesium with steam, you get a different product. So check this out. You get magnesium plus water. Obviously, the water is a gas this time because it's steam, it's gaseous. You get magnesium oxide, solid, white solid forming. And so what is the similarity between these two chemical reactions? Well, both of them form hydrogen gas. You can see the H2 on the end of each. What's the difference in the products? Well, the cold water forms magnesium hydroxide solution, and the steam forms magnesium oxide solid, white solid magnesium oxide. And here we go. You just got to learn that off by heart. That one in green is the one that's probably going to be hard to work out if you haven't learnt that particular one off by heart for AQA. Okay, let's go down to the last part of this question, which is 2.3. The reaction of calcium with water is a redox reaction. Explain in terms of oxidation states why this reaction involves both oxidation and reduction. So you all know oil rig. Oxidation is loss of electrons. Reduction is gain of electrons. This is a good way to remember what redox means. Now, we can write the equation out to help us with this. So just like a typical, most of the metals, calcium plus water, like the other alkali metals in group 1 and 2, it forms calcium hydroxide, and we get hydrogen gas given off. Lovely jubbly. Now all we need to do is check out their oxidation states and see what gets reduced and what's get oxidized. So calcium in its elemental form has an oxidation state of 0. When it's an ion in calcium hydroxide, it's got a +2 oxidation state, so it's lost 2 electrons, so it's been oxidized. Lost electrons, oil rig, oil. Oxidation is loss. Let's check out the hydrogen in water. When the hydrogen is in water, it's not really a hydrogen ion, but you get what I mean. It has a +1 charge, and it's gone from +1 to 0 in its elemental form, hydrogen gas. So it has gained an electron. It's been reduced. So while 2 marks, and the question is very specific, it says you need to talk about oxidation states. So you won't get the mark if you don't mention the oxidation states. So calcium loses 2 electrons, goes from 0 to +2. That's oxidation. Hydrogen gains an electron, goes from +1 to 0. And that is reduction. And that's going to get you both marks. All right, people. Don't forget sharing's caring. So hit the like, punch up the bell, subscribe, and let's get to the marks. I'll catch you on the next vid.
You're still here? It's over.